Time for a few more examples. What would be the integral, or what would be the antiderivative of 5e to the negative 3x? We've already done a little bit of this in the previous chapter. Remember that the derivative of e to the x is itself e to the x, which is very special and very cool in my opinion. So let's think about what the derivative of this would be. Notice that if we took the derivative of this, the negative 3 would come down. So that means if we're doing the antiderivative, we need to cancel that negative 3 somehow. And so here's what I'm going to suggest. And by the way, sometimes when you're doing an integral, you just do trial and error until you find something that works. Remember that it's really easy to check your answer because you can just take the derivative of your answer and see if you end up where you're supposed to end up. But what I'm going to suggest is that we should consider 5e to the negative 3x divided by negative 3. And don't forget our plus c. Notice that if we took the derivative of this, we take the derivative, zap. The derivative of 5e to the negative 3x is 5e to the negative 3x. But then we have to remember the chain rule. We have to take the derivative of negative 3x, which means that this would be multiplied by negative 3. That would then cancel the negative 3 on the bottom, and also the c cancels. So go ahead and try it for yourself. Take the derivative of this and see what you get. C goes away. This stays the same. The negative 3 comes out, which cancels the negative 3. Bingo, we're back where we wanted to be. So I guess another general rule we could do is if we have y equals, if we had little f of x is equal to, let's say ae to the bx, right? ae to the bx. Then that means the integral of f of x dx is equal to capital F of x plus c. And so what would that capital F of x be? That capital F of x would equal just a e to the bx divided by whatever your b value is, because that b value comes down and cancels the b underneath. And then obviously we don't want to forget our plus c. So you either put the plus c here or put the plus c here. Okay, let's do another example. 6x plus 5 squared. One thing you're going to learn, and I would explain this more in a full calculus class, but one thing you'll learn is that integrals are actually much harder to do than derivatives. You can take the derivative of almost anything thanks to the chain rule, but integrals are, interestingly, more difficult to do just out of the gate. That's why in your textbook you'll notice that there's actually a table of integrals, because some of them can be very, very tricky to derive. So in looking at this one, I actually can't think of a way to do this without simplifying this first. So what we'll do is we'll just FOIL this out like this, and we'll get 36x squared plus 30x plus 30x plus 25. And so we get the integral of 36x squared plus 60x plus 25. So all I did there, dx. Sometimes math teachers get annoyed when you leave off the dx. And honestly, you should leave the dx because this is part of the integral. It's part of the differential. Now, if I have the integral of all of this, 36x squared plus 60x plus 25, the integral can apply to each of these terms independently. So we could rewrite this like this. The integral of 36x squared plus the integral of 60x plus the integral of 25. And I've been a little bit bad right here because I've left off my dx's. So we'll add the dx each time. And you can think of the dx as like closing the integral. Like this integral starts here and ends right here. Now what we can do is just use our integral power rule. So this would equal the following. 36x cubed over 3 would be the first term. Take a look at that. Excuse me. Notice how if I took the derivative of that, it would work out. Plus 60x. I left off my c, so I'm going to put plus c1. The integral of this next one would be 60x squared over 2 plus c2, because maybe it's a different c. Plus the integral of 25 is 25x plus c3. So notice that if I took the derivative of each one of these, I'd get these answers up here. We can simplify this a little bit. Let's do 36 divided by 3, which is 12x cubed, plus 60 divided by 2 is 30, x squared plus 25x. And these c's are arbitrary, so I can kind of just collect them all into one big arbitrary plus big C. And since those C values can be whatever we want, we can just generalize all of them as just a big plus C, where this C can be whatever we want it to be. Let's do one last example in this video. Actually, we'll knock out both of them. So, before we integrate this, let's break it up. This would be the integral of 5x to the negative 1 dx. That's the first term. Minus the integral of 7e to the 5x dx is the second term. Plus the integral of the square root. Oops, I'm not going to write it like that. Let's write the square root of x to the 5. Let's rewrite that as the integral of x to the 5 divided by 2 dx. That'll make it a little bit easier for us to do the power rule. Here we go. I'm going to do this one a little quick, but you can check my answer if you want. This will be 5x to the negative 2 over negative 2. Minus, we saw earlier that this will be 7e to the 5x divided by 7. I'm sorry, divided by 5. I made a mistake. Divided by 5. Because the 5 comes down due to the chain rule. And this will be plus x to the 7 over 2 divided by 7 over 2. And then we have one big plus c. So you can see I did that pretty quickly. That's because I've done very many of these, and you will get faster at them with practice. But just notice that if you took the derivative of any of these three terms, you would get the term up here. Let's just clean this up a little bit. Our final answer you can write as 5 over x squared with a negative in front, minus 7/5 e to the 5x, plus 2/7 x to the 7 over 2 plus c. That's maybe a little bit cleaner of an answer. Honestly, though, if you put either one of these on a test, I'd give you full credit. This one has one additional step, so let's go ahead and tackle that in the next video because this is getting a little long. If you have any questions, please send me an email.